Hello everyone. Today we'll be solving the problem number 36, valid Sudoku. So let's see what the problem states. Then we will discuss the approach as well as the edge cases along with writing the code. Finally, we'll be discussing about the time complexity and the space complexity of the written code. Right. So first, let's see what the question states here. So you can just go through the question and try to understand the question with the example. I'll just summarize the question so that it will be easier to understand. Right. So what the question states here, the problem is to check if a partially filled 9 into 9 Sudoku board is valid or not here. Let's come to example here. Yeah, the main problem here, what we have to check here, the problem is to check if the partially filled 9 into 9 Sudoku board is valid or not. So what is a valid Sudoku then? A valid Sudoku board satisfies the following things. Just keep this in mind. So each row must contain digits 1 to 9 without repetition. Each row here, these are the rows, right? Each row must contain 1 to 9 digits without repetition. This is first thing. And second thing is each column must contain 1 to 9 without repetition. So here we have to consider column as well. So first column you can see 5, 6, this one or this one here. This every column must contain digits 1 to 9 without repetition. And the final one is each 3 into 3 subgrid. This one, while I say 3 into 3 subgrid, this one, if you have played Sudoku, you should be knowing, right? These three things. First 3 into 3 grid, I'm just considering here this one, right? So here each 3 into 3 subgrid referred to as subbox. Here we are referring the subgrid or 3 into 3 subgrid as subbox. Just keep in mind, we are referring 3 into 3 subgrid as subbox. It must also contain the digits 1 to 9 without a repetition. So these are the three things we have to keep in mind. So then what are the key points that we need to remember here? Cells with dot are ignored as they are empty. Here you can see dot here. You can clearly see cells with dot, they are ignored here because they are empty. So empty, this one empty cell is represented by the dot. We are ignoring that one. That we have to keep in mind. And the board only needs to be validated here. This one we are validating the entire board. We are not solving any Sudoku here. Just keep in mind here. This is important thing. We are not solving anything here. We are not solving any Sudoku thing here. We are just making sure that the board needs to be validated according to the conditions that they have given, right? This is simple. So let's go with the approach first. So let's discuss the approach, then we will discuss about the edge cases and then write the code, right? So let's discuss the approach step by step. So I'll just give here, just give me a second here. So first thing we need to consider, we need to consider is we'll be using the hash sets, 3 hash sets. One is to track the scene digits for rows and one for the columns and one for the sub boxes. So just keep in mind, we will be making use of the hash sets, right? We'll be making use of the 3 hash sets. One to this one to track the scene digits for rows, one for rows and one for columns and one for sub boxes. So we are referring the 3 into 3 subgrid as this one, sub boxes, right? As we had discussed in the question. So one for the sub box. We will be making use of the hash sets, 3 hash sets. This one we have to keep in mind. So what will be the approach? What are all the things that we need to consider here? First one, we need to go with the row validation, right? So I'll just give here row validation. So what we need to consider here, we have to maintain a hash set for each row. So while I say we have to maintain the hash set for each row, why we are making use of the hash set? Because the numbers should not repeat right? We should have the numbers from 0 to 9 and the number should not repeat. So that is the reason we'll be maintaining a hash set for each row. If a digit repeats in any row, then it is invalid. If digits repeat in row, then we know that board is invalid. This is where this is for the row validation. Next, let's move on with the column validation, right? So I'll just give here column validation. So here the same thing, similar thing, we'll be maintaining a hash set for the each column. If a digit repeats in any column, then the board is invalid. If digits repeat in any column, then the board is invalid, right? This is simple. Next, same goes with the sub box as well. So I'll just come here. Let me give here sub box validation. So here we will be maintaining a hash set for each sub box as well. Here, similar to the column validation and the row validation, we'll be maintaining a hash set for each sub box. And also one thing we need to remember here is sub box indices are calculated by this one. So math.floor, instead of the math.floor, we can make use of the double tilde operator as well, right, in the JavaScript. So I'll just be making use of the double tilde operator. So here this will be row by 3, math.floor of row by 3 into 3 plus again math.floor of this one column by 3. Nothing but instead of math.floor, I have made use of the double tilde operator. This is fine. So we are going with the this formula, math.floor of row by 3 into 3 plus math.floor of column by 3. So again, here the same thing. If the digit repeats in sub box, then the board is invalid. So if digits repeats in sub box, then the board is invalid, right here. This is where if digits repeat in sub box, then the board is said to be invalid. Now we know that. So we have discussed here, we will be making use of the 3 hash set. One is for rows, one is for columns, and one is for the sub box. Here for the row validation, if digits repeat in row, then the board is invalid. If this one, digits repeat in any column, board is invalid. This one will be going with this formula for the sub box. And if the digits repeat in sub box, then the board is invalid. These 3 things we have to keep in mind. And finally, we will be iterating through the each cell of the board. We have to iterate through the each cell of the board and perform these checks simultaneously, right? So we have to perform these checks simultaneously by iterating through the each cell of the board. If a duplicate is found in any row, column, or the sub box, the board is said to be invalid. That's what we saw here, right, till now. And if no duplicates are found, then the board is said to be valid. If no duplicates are found, then the board is said to be valid. So I hope this is clear. Next, let's consider all the edge cases and then write the code. So just give me a second here. So here let's discuss the edge cases. First one is empty board. You can clearly see here while explaining the question, I said that if we are having the dot, so this is empty cell and we are ignoring this one, right? So here basically we have complete empty board, means it is 9 into 9 Sudoku board is filled with this one. Each cell is empty here, right? So the output is true here. Why the output is true here? An empty board is always valid. They have mentioned in the question, an empty board is always valid. So the output will be true here for this one, right? So I hope this is clear, the first edge case. Let's come to the second, second edge case, nothing but duplicate in rows. You can clearly see here, we are having the same number in the same row. Here in the first row, this is first row, right? Here in the same this one first row, we are having 2 5s. So 2 5s we have found in the first row. So this is basically this is not a valid Sudoku board. Hence the output will be false here. So next, let's move on to the third edge case. Here, the third edge case that we are going here is duplicate in column. We can clearly see here the first column, this one, what we are considering here, the first column. In this one, we have 2 5s, means the number 5 is repeated again here in the first column. We can clearly see, right? So the output that we need to get here is false. This is the third edge case. And finally, we'll go with the last edge case. Nothing but duplicate in sub box, right? Just give me a second here. So while I said duplicate in the sub box, so here we can clearly see we have to consider 3 into 3 subgrade, right? So this one is 3 into 3 subgrade, and here we know that 5 is getting repeated twice here. You can see here. Here also you can see 5 is getting repeated twice. The same number should not get repeated in the 3 into 3 subgrade, right? So here 5 is getting repeated. This is also invalid and the output will be false. These are the 4 edge cases that we need to consider. So next, let's write the code. While writing the code, I'll explain the code as well, and then we'll be discussing about the time complexity and the space complexity as well. Now, as we have understood the approach as well as we have seen the edge cases as well. Now it is easier to write the code, right? First, initially, as we had this one discussed in the approach, we'll be initializing 3 sets to track scene numbers in rows, columns, and 3 into 3 subgrid or 3 into 3 boxes. Let's write this one quickly. I'll just give here let rows equals. We'll just make use of array from. So initially, we will keep the length as 0 here. This is fine. And let me give here, let's make use of set here. So I hope this is clear. We are keeping one set for each row, right here. We have to keep one set for each column as well. And also we have to keep one set for each 3 into 3 sub box or 3 into 3 subgrid. Here, let me copy the same thing and make the changes very quickly here. Just come here. I'll just make this columns, and this one, I'll just consider this one as boxes here. This will remain same. So here, this has to be length 9, not length 0, right? We are going with 9 into 9 bold. Sorry. Yeah, this is fine. Let me format this once. What we have done here, we are initializing the sets to track scene numbers in rows, columns, and 3 into 3 boxes. Nothing but here, this one, first line, one set for each row. Second line, one set for each column. And this one, one set for each 3 into 3 sub boxes, right? So next what we will do, we will iterate over each row. So let me quickly write here. I'll just consider r equals 0. Sorry, what did I give here? This has to be equals, right? So then r less than 9, r plus plus. So we are just iterating over each row, and then let's iterate over each column in the current row as well. For this one, I'll just give here c equals 0, c less than 9. Let's increment this one. This is fine. Within this one, let's get the current cell value initially. For that one, I'll just make sure, I'll just make use of the variable name val. I'll just set this one to bold of row and column within the array, right? So we are just getting the current cell value, right? After getting the current cell value, let's skip the empty cells. That was also one condition, right? We have to skip the empty cells, nothing but dot, right? So if we have already considered the variable name val, right? If val, let's compare this one with the dot, then I'll just give here continue. So after skipping the empty cells, we have to calculate the index of 3 into 3 box for the current cell. How can we calculate? While discussing the approach, we discussed the formula to calculate the index of 3 into 3 box for the current cell. So I'll just give here box index equals math.floor. Instead of math.floor, I'll just make use of the double tilde operator. So I'll just give here row by 3, r by 3. I have considered r, right? So into 3 plus, instead of math.floor, I'll just go with the double tilde operator again. This one will be c by 3. Hope this is clear. So next what we'll do, after calculating the index of 3 into 3 box for the current cell, we will check if the value already exists in the current row, column or the box. So I'll just write a simple if condition for this. I'll just give here rows of r dot has of value. Same thing for the column as well. I'll just give here columns I have considered, right? COLS here. Sorry. Yeah. C has again value. Same thing goes with the boxes as well here. Boxes of so we have to consider this one, right? Box index for this. So I'll just go with the box index here. This one, the formula. This one, right? This variable. So box index, this one has a value. So we are just checking if the value already exists in the current row, column or the box. So if the value already exists, then it is invalid Sudoku. If the value is getting repeated, we saw that one, right? So we saw that one in the edge case. So I'll just return false here. So this is invalid Sudoku because duplicate has been found here. So after this, I'll just come out of this one. So we have to add the value to the respective row, column and the box sets as well. For that one, I'll just make use of the add here. I can simply give here rows of dot add of val. So let me copy the same thing twice here and make the necessary changes here. So I'll just make this one columns, this one finally boxes. So instead of r here, let me make this one box index, and here instead of r, I'll just make this one c. This is fine. I'll just come out of this one. Finally, what we have to do, we have to return, just give me a second here. So yeah, we have to return true, or we have to show that the Sudoku board is valid if no duplicates are found, right? For that one, I'll just be giving here return true. So let me format this one once. Let's hit the run. Let's hit the run button. Yeah, this is getting accepted. So this one sample test cases are getting passed. So I'll just hit the submit now. So you can clearly see the code works absolutely correct. So I hope the question is completely clear and you are okay with the solution as well. So this is it for now. Thanks for watching, guys. So before this one, let's discuss the time complexity and the space complexity as well. So I forgot this one, sorry. So let's discuss the time complexity and the space complexity very quickly, and then I'll just finish the video. So I'll just come here. So what would be the time complexity and the space complexity here? The time complexity would be big O of 1 here. Why the time complexity is big O of 1 here? Because we know that the board size is 9 into 9. We are making use of the 9 into 9 Sudoku board, right? So the board size is fixed 9 into 9, and the operations involve a constant amount of work. Hence, the time complexity here is big O of 1. This is simple. And what would be the space complexity here? The space complexity would be big of 1 as well. Why? The space required for the 27 sets. So we are making use of the 27 sets, right? 9 rows, 9 columns and 9 sub boxes. The space required for the 27 sets is constant. So the space complexity would be big of 1 as well. So yeah, I hope this is completely clear. So for now, this is it. Thanks for watching, guys.